Our next one is called a surjective or onto function. Now, by the way, just for onto is literally one word, so long story. But anyway, so every element in the codomain, maps to at least one element in the domain. So notice this is empty. The Bermuda Triangle is completely empty. The range and the codomain are a perfect match. There's nobody left behind here. And again, notice that these, as long as there's a match for everyone has a mapping to it, we're in good shape. Now, by the way, look at D and E. Both of them ended up at 2. Fine, but at least both of them are being used. There's nobody that's left behind for an onto function. Here's a question that you're going to see in your book, your homework, whatever. It's broken down into 2 parts. What we're doing is we're showing the same function, but we're asking to see if it's surjective for all values that are all real numbers, which honestly is going to be easy. But part 2 is going to be that we're going to say, hey, it's for all numbers that are integers. That one's going to be a little bit more interesting. So as you know, but I still put a note up here, real numbers are basically any and all numbers you can think of. Whereas integers, you know, they're going to be a little bit different. By the way, for integers, it's going to be all of the integers. That's what it asked for originally, so just heads up. So anyway, what am I going to do here? So I am going to go ahead and use the function and try to solve for x. Why am I going to do that? Because what I'm going to do is, once I solve for x, which ends up being y minus 2 over 5, I'm going to put any number that I want in there, but to be honest with you, I'm going to put 1 and then 23. Sometimes I'll put a negative number in there. Notice this isn't exactly a proof, by the way. But you could do a drawing after this is done using the blob system. Anyway, so if I put 1 in for y, overall it'd be negative 1 minus, sorry, it'd be 1 minus 2, wow, equals our negative 1 over 5. Then we can, that is a real number. I tried 23. It's going to end up as 4 and 1/5. Yes, both of those are real numbers. It's almost hard to screw this one up, let's put it that way. But that one does work out. But I'm going to try to do the exact same thing when it comes to our elements in x are going to be all integers. Now, so same as above, the exact same thing is set up, but this time I'm going to try 7, 23, and honestly I'm surprised I didn't try a negative number just for the giggles of it, but anyway, when we have 7, we have the 7 minus 2 is 5, so 5 over 5 is equal to 1. So yeah, hey, that worked out. But I'm going to use that same 23, and we end up with 4 and 1/5 again. That's not an integer. So that's not going to work with integers, but it can, that function can work and be surjective for all of our real values. Now, what did I mean by that? Number one, I can put anything in here, and those values, it can be picked up as a real number, any of those numbers. Here, I'm going to have values that frankly aren't going to be integers. So it doesn't hit all of the items that are in the possible y codomain portion of our function. So that's why we have a no here and we have a yes up here. It's literally the range of values between integers and all real